Welcome to Emilac Online tutorial. Now let's look at this question. Now, reflection of light rays. Now, two plane mirrors M1 and M2 are inclined at 90 as shown. Now here is the diagram. Now a ray of light OP, this OP here, is incident on M, which means here. Now at P and emerges from M2 along QE, which means the ray of light came here, went here and left that way. Okay, now find the angle of reflection at the second mirror, which means you have to find the angle here, the angle of reflection at this part, which is the second mirror, and find the deviation of the ray after the reflection by the two mirror. All right, first of all, I will redraw this diagram here for a better explanation. Now here's the diagram. Okay, now this is the ray of light, which means it actually came in here. Now this is the incident ray. Now that and strikes at P, then it implies that at this point is the normal. As long as it struck at this point and reflected, then here is the normal. Okay, now let us recall that according to the law of reflection, that the angle of incidence equals to the angle of what? Reflection, right? Now, for us to get the angle of incidence, now the angle of incidence is the angle that is formed within the incident ray and the normal. Okay, so here will definitely be the angle of what? Incidence. Now take note that the whole of here is 90 degree, and if the whole of here is 90 degree and this part here is 35, which means 90 minus 35 should give us 8, that will be 55. So here is what? 55. Okay, all right. Now if here is 55, definitely the refracted ray here will then be 55, right? All right, so to that end, it also implies here that here is also what? 35. Now let's take a look now. Now this is the incident ray. Now strike here as it reflects towards this end. On getting to this mirror here, this ray here becomes the incidence, that means the incident ray on the second mirror. So on striking here, it implies also that here is the normal. Okay, all right. Now to this part here now take note. So as it moves here also, here and left. So the incident ray for the mirror 2, that is M2 here, this is M1, is this ray. Okay, all right. So at this point here now, how then do you calculate this? Now take note, this is 35, right? This is 90. Definitely here will also be what? 55. Now if it is 55, then here also will definitely be 55. That will be 35. Okay, and since the incident ray I equals to the reflected ray, so R here also will now be what? 35. Okay, so here is the refracted ray. So to this end, R at the second mirror equals to 35 degree. Okay, now let us now look at find the deviation of the ray after the reflection by this by the two mirror. Now for us to get the deviation first, now this is the incident ray. Normally this is the path through which this ray is meant to pass without this mirror, right? So now it definitely means it deviated from here down to this part here. Okay, all right. Now to this end now, it implies that here is no, here should be 70, that will be 35. Okay, so that will be 35. So to this end here now, the deviation here will now be 35 plus 35, which will give us what? 70 degree. Okay, all right. So the deviation here also will come over like this. Okay, now at this point, it means the deviation from here will now be from here down to this part here. Now if here is 35, definitely here will be 55. Now here also will be 55. Okay, yes. All right, to this end, the whole of here is 110, because 55 plus 55, let's see, this is 0, 11. Okay, so now the deviation of the ray after the reflection by the two mirrors will now be, let us say, D will now be D1 plus D2, which means the deviation here D1 and the deviation here D2. So which will now give us 70 plus 110, should give us what? 180. Alright, okay, so that's the final answer. If you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.